Once you have the raw sound being generated by a VCO, you need to be able to do something with that in order to make the sound more interesting. The VCO itself always produces a maximum amplitude and constant amplitude signal. First processor I'll consider here is the voltage controlled amplifier. So the triangle shape denotes the idea of an amplifier, and the gain of the amplifier is established by the control voltage, or CV for short. For example, we could use a standard that 0 volts corresponds to a gain of 0, and 1 volt corresponds to a gain of 1. Gain of 0 is also the same thing when expressed as dB, is essentially minus infinite dB, and a gain of 1 would be 0 dB. You'll probably oftentimes see references in terms of decibels instead of just pure gain. But that way the VCA has the ability to basically either shut off the sound or make it maximum intensity or anything in between. Next, I'll consider a filter device, and this is called the VCF, or voltage controlled filter. And these are very important because they give us the ability to shape the spectrum of the signal. And things we might adjust with our control voltages would be, say, the corner frequency, the bandwidth. If we were using a second order style filter, we can vary the gain at the resonance frequency. For example, if we had a transfer characteristic for a low pass filter, then you can imagine that the corner frequency could essentially be varied continuously by this control voltage. Gain at resonance, you can adjust the amount of peaking that happens at the corner frequency. Also, we're not restricted just to low pass filters. We could have a band pass filter, for example, and in this case we could have another control voltage that can influence the bandwidth, whether or not that's wide or narrow, and we can also move the center frequency.